Welcome to the second course in the Google Data Analytics Certificate. If you completed Course 1, we met briefly at the beginning. But for those of you who are just joining us, my name is Ximena and I'm a Google Finance Data Analyst. I think it's really wonderful that you're here with me learning about the fascinating field of data analytics. Learning and education have always been very important to me. When I was young, my mom always said, I can't leave you an inheritance, but I can give you an education that opens doors. That always pushed me to keep learning, and that education gave me the confidence to apply for my job at Google. Now, I get to do really meaningful work every day. Just recently, I worked as an analyst on a team called Verily Life Sciences. We were helping to get life-saving medical supplies to those who need it most. To do this, we forecasted what healthcare professionals would need on hand and then shared that information with networks. The information that my team provided helped make data-driven decisions that actually saved lives. I'm thrilled to be your instructor for this course. We're going to talk about the difference between effective and ineffective questions and learn how to ask great questions that lead to insights that can help you solve business problems. You will discover that effective questions help you to make the most of all the data analysis phases. You may remember that these phases include ask, prepare, process, analyze, share, and act. In the ask step, we define the problem we're solving and make sure that we fully understand stakeholder expectations. This will help keep you focused on the actual problem, which leads to more successful outcomes. So we'll begin this course by talking about problem solving and some of the common types of business problems that data analysts help solve. And because this course focuses on the ask phase, you'll learn how to craft effective questions that help you collect the right data to solve those problems. Next, we'll talk about the many different types of data. You'll learn how and when each is the most useful. You'll also get a chance to explore spreadsheets further and discover how they can help make your data analysis even more effective. And then we'll start learning about structured thinking. Structured thinking is the process of recognizing the current problem or situation, organizing available information, revealing gaps and opportunities, and identifying the options. In this process, you address a vague, complex problem by breaking it down into smaller steps. And then those steps lead you to a logical solution. We'll work together to be sure you fully understand how to use structured thinking in data analysis. Finally, we'll learn some proven strategies for communicating with others effectively. I can't wait to share more about my passion for data analytics with you, so let's get started. In this video, I'm going to share an interesting data analytics case study. It will illustrate how problem solving relates to each phase of the data analysis process and shed some light on how these phases work in the real world. It's about a small business that used data to solve a unique problem it was facing. The business is called Anywhere Gaming Repair. It's a service provider that comes to you to fix your broken video game systems or accessories. The owner wanted to expand his business. He knew advertising is a proven way to get more customers, but he wasn't sure where to start. There are all kinds of different advertising strategies, including print, billboard, TV commercials, public transportation, podcasts, and radio. One of the key things to think about when choosing an advertising method is your target audience. In other words, the specific people you're trying to reach. For example, if a medical equipment manufacturer wanted to reach doctors, placing an ad in a health magazine would be a smart choice. Or, if a catering company wanted to find new cooks, it might advertise using a poster at a bus stop near a cooking school. Both of these are great ways to get your ad seen by your target audience. The second thing to think about is your budget and how much the different advertising methods will cost. For instance, a TV ad is likely to be more expensive than a radio ad. A large billboard will probably cost more than a small poster on the back of a city bus. The business owner asked the data analyst, Maria, to make a recommendation. She started with the first step in the data analysis process, ask. Maria began by defining the problem that needed to be solved. To do this, she first had to zoom out and look at the whole situation in context. That way, she could be sure that she was focusing on the real problem and not just its symptoms. This leads us to another important part of the problem-solving process, collaborating with stakeholders and understanding their needs. For Anywhere Gaming Repair, stakeholders included the owner, the vice president of communications, and the director of marketing and finance. Working together, Maria and the stakeholders agreed on the problem, not knowing their target audience's preferred type of advertising. Next up was the prepare phase, where Maria collected data for the upcoming analysis process. But first, she needed to better understand the company's target audience, people with video game systems. After that, Maria collected data on the different advertising methods. This way, she would be able to determine which was the most popular one with the company's target audience. Then, she moved on to the process step. Here, Maria cleaned the data to eliminate any errors or inaccuracies that could get in the way of the result. As we've learned, when you clean data, you transform it into a more useful format, create more complete information, and remove outliers. Then it was time to analyze. In this step, Maria wanted to find out two things. First, who's most likely to own a video gaming system? And second, where are these people most likely to see an advertisement? Maria first discovered that people between the ages of 18 and 34 are most likely to make video game-related purchases. So, she could confirm that Anywhere Gaming Repair's target audience was people 18 to 34 years old. This was who they should be trying to reach. With this in mind, Maria then learned that both TV commercials and podcasts are very popular with people in the target audience. Because Maria knew Anywhere Gaming Repair had a limited budget and understanding the high cost of TV commercials, her recommendation was to advertise in podcasts because they are more cost-effective. Now that she had her analysis, it was time for Maria to share her recommendation so the company could make a data-driven decision. She summarized her results using clear and compelling visuals of the analysis. This helped her stakeholders understand the solution to the original problem. Finally, Anywhere Gaming Repair took action. They worked with a local podcast production agency to create a 30-second ad about their services. The ad ran on podcast for a month, and it worked. They saw an increase in customers after just the first week. By the end of week 4, they had 85 new customers. There you go, effective problem solving using data analysis phases in action. Now you've seen how the 6 phases of data analysis can be applied to problem solving and how you can use that to solve real-world problems.
I'm Nikki, and I manage the Education, Evaluation, Assessment, and Research team. My favorite part of the data analysis process is finding the hardest problem and asking a million questions about it and seeing if it's even possible to get an answer. So one of the problems that we've tackled here at Google is our nuclear onboarding program, which is how we onboard new hires. One of the things that we've done is ask the question, how do we know whether or not newglers are onboarding faster through our new onboarding program than our old onboarding program, where we used to lecture them? And we worked really closely with the content providers to understand just exactly what does it mean to onboard someone faster. Once we asked all the questions, what we did is we prepared the data by understanding who was the population of the new hires that we were examining. So we prepared our data by going through and understanding who our populations were, by understanding who our sample set was, who our control group was, who our experiment group was, where were our data sources, and make sure that it was in a format that was clean and digestible for us to write the proper scripts for. So the next step for us was to process the data to make sure that it was in a format that we could actually analyze in SQL, making sure that it was in the right format and in the right columns and in the right tables for us. To analyze the data, we wrote scripts in SQL and in R to correlate the data to the control group or the experiment group and interpret the data to understand Were there any changes in the behavioral indicators that we saw? Once we analyze all the data, we want to report on it in a way that our stakeholders could understand. So depending on who our stakeholders were, we prepared reports, dashboards, and presentations, and share that information out. Once all of our reports were complete, we saw really positive results and decided to act on it by continuing our project-based learning onboarding program. It was really satisfying to know that we had the data to support it and that it really, really worked. And not just that the data was there, but that we knew that our students were learning and that they were more productive faster back on their jobs.
Before, I shared how data analysis helped a company figure out where to advertise its services. An important part of this process was strong problem-solving skills. As a data analyst, you'll find that problems are at the center of what you do every single day. But that's a good thing. Think of problems as opportunities to put your skills to work and find creative and insightful solutions. Problems can be large or small, simple or complex. No problem is like another, and they all require a slightly different approach. But the first step is always the same: understanding what kind of problem you're trying to solve. And that's what we're going to talk about now. Data analysts work with 6 basic problem types: making predictions, categorizing things, spotting something unusual, identifying themes, discovering connections, and finding patterns. Think back to our real-world example from the previous video. In that example, Anywhere Gaming Repair wanted to figure out how to bring in new customers. So, the problem was how to determine the best advertising method for Anywhere Gaming Repair's target audience. To help solve this problem, the company used data to envision what would happen if it advertised in different places. Now, nobody can see the future, but the data helped them make an informed decision about how things would likely work out. So, their problem type was making predictions. Now, let's think about the second problem type, categorizing things. Here's an example of a problem that involves categorization. Let's say a business wants to improve its customer satisfaction levels. Data analysts could review recorded calls to the company's customer service department and evaluate the satisfaction level of each caller. They could identify certain keywords or phrases that come up during the phone calls and then assign them to categories such as politeness, satisfaction, dissatisfaction, empathy, and more. Categorizing these keywords gives us data that lets the company identify top-performing customer service representatives and those who might need more training. This leads to happier customers and higher customer service scores. Okay, now let's talk about a problem that involves spotting something unusual. Some of you may have a smartwatch. My favorite app is for health tracking. These apps can help people stay healthy by collecting data such as their heart rate, sleep patterns, exercise routine, and much more. There are many stories out there about health apps actually saving people's lives. One is about a woman who was young, athletic, and had no previous medical problems. One night, she heard a beep on her smartwatch. A notification said her heart rate had spiked. Now, in this example, think of the watch as a data analyst. The watch was collecting and analyzing health data. So, when her resting heartbeat rate was suddenly 120 beats per minute, the watch spotted something unusual because according to its data, the rate was normally around 70. Thanks to the data her smartwatch gave her, the woman went to the hospital and discovered she had a condition which could have led to life-threatening complications if she hadn't gotten medical help. Now let's move on to the next type of problem, identifying themes. We see a lot of examples of this in the user experience field. User experience designers study and work to improve the interactions people have with products they use every day, like apps, websites, and even coffee makers. Let's say a user experience designer wants to see what customers think about the coffee maker his company manufactures. This business collects anonymous survey data from users, which can be used to answer this question. But first, to make sense of it all, he will need to find themes that represent the most valuable data, especially information he can use to make the user experience even better. So, the problem the user experience designer's company faces is how to improve the user experience for its coffee makers. The process here is kind of like finding categories for the keywords and phrases in customer service conversations. But identifying themes goes even further by grouping each insight into a broader theme. Then, the designer can pinpoint the themes that are most common. In this case, he learned users often couldn't tell if the coffee maker was on or off. He ended up optimizing the design with improved placement and lighting for the on-off button, leading to product improvement and happy users. Now we come to the problem of discovering connections. This example is from the transportation industry and uses something called third-party logistics. Third-party logistics partners help businesses ship products when they don't have their own trucks, planes, or ships. A common problem these partners face is figuring out how to reduce wait time. Wait time happens when a truck driver from a third-party logistics provider arrives to pick up shipment, but it's not ready, so she has to wait. That costs both company time and money, and it stops the trucks from getting back on the road to make more deliveries. So how can they solve this? Well, by sharing data, the partner companies can view each other's timelines and see what's causing shipments to run late. Then they can figure out how to avoid those problems in the future, so a problem for one business doesn't cause a negative impact for the other. For example, if shipments are running late because one company only delivers Monday, Wednesdays, and Fridays, and the other company only delivers Tuesdays and Thursdays, then the companies can adjust to do deliveries on the same day to reduce waiting time for customers. Alright, we've come to our final problem type, finding patterns. Oil and gas companies are constantly working to keep their machines running properly. So the problem is how to stop machines from breaking down. One way data analysts can do this is by looking at patterns in the company's historical data. For example, they could investigate how and when a particular machine broke down in the past and then generate insights into what led to the breakage. In this case, the company saw a pattern indicating that machines began breaking down at faster rates when maintenance wasn't kept up in 15-day cycles. They can then keep track of current conditions and intervene if any of these issues happen again. You've now learned the 6 basic problem type data analysts typically face. As a future data analyst, this is going to be valuable knowledge for your career.
Hi, I'm Anmol. I'm the head of large advertiser marketing analytics within the marketing team at Google. At its core, my job is about connecting the right user with the right message at the right time. The first step is really to get a broad sense of a certain pattern that's occurring. So, for example, we know that this particular segment of users is more responsive to this type of content. Once we're able to actually see this hypothesis through the data, we do testing to ensure that the hypothesis is actually correct. So, for example, we would test sending these pieces of content to this segment of users and actually verify within a controlled environment whether that response rate is actually higher for that type of content or whether it isn't. And so once we're able to actually verify that hypothesis, we go back to the stakeholders, in this case our marketers, and say, we've actually proven within a relatively high degree of certainty that this particular segment is more responsive to this type of content. And because of that, we're recommending that you produce more of this type of content. And so our stakeholders really get to see the whole sort of evolution from hypothesis to proven concept. And they're able to come with us on the journey on how we're proving out these hypotheses and then eventually turning them into strategies and recommendations for the business. So the outcome in this case was that we were able to actually change the way our whole marketing team worked to actually make it much more user-centric. So instead of, from our perspective, coming up with content that we think the users need, we're actually going in the other direction of figuring out what users need first, proving that they need certain things or they don't need certain things, and then using that information going back to marketers and coming up with content that fulfills their need. So it really changed the direction of how we produce things.
now that we've talked about 6 basic problem types, it's time to start solving them. To do that, data analysts start by asking the right questions. In this video, we're going to learn how to ask effective questions that lead to key insights you can use to solve all kinds of problems. As a data analyst, I ask questions constantly. It's a huge part of the job. If someone requests that I work on a project, I ask questions to make sure we're on the same page about the plan and the goals. And when I do get a result, I question it. Is the data showing me something superficially? Is there a conflict somewhere that needs to be resolved? The more questions you ask, the more you learn about your data and the more powerful your insights will be at the end of the day. Some questions are more effective than others. Let's say you're having lunch with a friend and they say, "These are the best sandwiches ever, aren't they?" Well, that question doesn't really give you the opportunity to share your own opinion, especially if you happen to disagree and didn't enjoy the sandwich very much. This is called a leading question because it's leading you to answer in a certain way. Or maybe you're working on a project and you decide to interview a family member. Say you ask your uncle, "Did you enjoy growing up in Malaysia?" He may reply, "Yes," but you haven't learned much about his experiences there. Your question was closed-ended. That means it can be answered with a yes or no. These kinds of questions rarely lead to valuable insights. Now, what if someone asks you, "Do you prefer chocolate or vanilla?" Well, what are they specifically talking about? Ice cream, pudding, coffee flavoring, or something else? What if you like chocolate ice cream but vanilla in your coffee? What if you don't like either flavor? That's the problem with this question. It's too vague and lacks context. Knowing the difference between effective and ineffective questions is essential for your future career as a data analyst. After all, the data analyst process starts with the ask phase. So it's important that we ask the right questions. Effective questions follow the SMART methodology. That means they're specific, measurable, action-oriented, relevant, and time-bound. Let's break that down. Specific questions are simple, significant, and focused on a single topic or a few closely related ideas. This helps us collect information that's relevant to what we're investigating. If a question is too general, try to narrow it down by focusing on just one element. For example, instead of asking a closed-ended question like, "Are kids getting enough physical activities these days?" ask, "What percentage of kids achieve the recommended 60 minutes of physical activity at least 5 days a week?" That question is much more specific and can give you more useful information. Now, let's talk about measurable questions. Measurable questions can be quantified and assessed. An example of an unmeasurable question would be, "Why did our recent video go viral?" Instead, you could ask, "How many times was our video shared on social channels the first week it was posted?" That question is measurable because it lets us count the shares and arrive at a concrete number. Okay, now we've come to action-oriented questions. Action-oriented questions encourage change. You might remember that problem solving is about seeing the current state and figuring out how to transform it into the ideal future state. Well, action-oriented questions help you get there. So, rather than asking, "How can we get customers to recycle our product packaging?" you could ask, "What design features will make our packaging easier to recycle?" This brings you answers you can act on. All right, let's move on to relevant questions. Relevant questions matter, are important, and have significance to the problem you're trying to solve. Let's say you're working on a problem related to a threatened species of frog, and you asked, "Why does it matter that Pine Barrens tree frogs started disappearing?" This is an irrelevant question because the answer won't help us find a way to prevent these frogs from going extinct. A more relevant question would be, what environmental factors changed in Durham, North Carolina between 1983 and 2004 that could cause Pine Barrens tree frogs to disappear from the Sandhills region? This question would give us answers we can use to help solve our problem. That's also a great example for our final point. time-bound questions. Time-bound questions specify the time to be studied. The time period we want to study is 1983 to 2004. This limits the range of possibilities and enables the data analyst to focus on relevant data. Okay, now that you have a general understanding of SMART questions, there's something else that's very important to keep in mind when crafting questions: fairness. We've touched on fairness before, but as a quick reminder, fairness means ensuring that your questions don't create or reinforce bias. To talk about this, let's go back to our sandwich example. There, we had an unfair question because it was phrased to lead you toward a certain answer. This made it difficult to answer honestly if you disagreed about the sandwich quality. Another common example of an unfair question is one that makes assumptions. For instance, let's say a satisfaction survey is given to people who visit a science museum. If the survey asks, "What do you love most about our exhibits?" this assumes that the customer loves the exhibits, which may or may not be true. Fairness also means crafting questions that make sense to everyone. It's important for questions to be clear and have a straightforward wording that anyone can easily understand. Unfair questions also can make your job as a data analyst more difficult. They lead to unreliable feedback and missed opportunities to gain some truly valuable insights. You've learned a lot about how to craft effective questions, like how to use the SMART framework while creating your questions, and how to ensure that your questions are fair and objective. Moving forward, you'll explore different types of data and learn how each is used to guide business decisions. You'll also learn more about visualizations and how metrics or measures can help create success. It's going to be great.
Hi, I'm Evan. I'm a learning portfolio manager here at Google. And I have one of the coolest jobs in the world, where I get to look at all the different technologies that affect big data and then work them into training courses like this one for students to take. I wish I had a course like this when I was first coming out of college or high school. It was honestly a data analyst course that's geared in the way like this one is, if you've already taken some of the videos, really prepares you to do anything you want. It'll open all of those doors that you want for any of those roles inside of the data curriculum. Well, what are some of those roles? There are so many different career paths for someone who's interested in data. Generally, if you're like me, you'll come in through the door as a data analyst, and you'll be working with spreadsheets, you'll be working with small, medium, and large databases, but all you have to remember is 3 different core roles. Now, there's many, and there's specialties within each of these different careers, but these 3 are the data analyst, which is generally someone who works with SQL, spreadsheets, databases, might work as a business intelligence team creating those dashboards. Now, where does all that data come from? Generally, a data analyst will work with a data engineer to turn that raw data into actionable pipelines. So you have data analysts, data engineers, and then lastly, you might have data scientists who basically say, the data engineers have built these beautiful pipelines. Sometimes the analysts do that too. The analysts have provided us clean and actionable data, and the data scientists then work to actually turn it into really cool machine learning models or statistical inferences that are just well beyond anything you could have ever imagined. And we'll share a lot of resources and links for ways that you can get excited for each of these different roles. And the best part is, if you're like me, when I went into school, I didn't know what I wanted to do. And you don't have to know at the outset which path you want to go down. Try them all. See what you really, really like. It's very personal. Becoming a data analyst is so exciting. Why? Because it's not just like a means to an end. It's taking on a career path where so many bright people have gone before and have made the tools and technologies that much easier for you and me today. For example, when I was starting to learn SQL, or the structured query language that you're going to be learning as part of this course, I was doing it on my local laptop, and each of the queries would take like 20, 30 minutes to run. And it was very hard for me to keep track of the different SQL statements that I was writing or share them with somebody else. That was about 10 or 15 years ago. Now, through all the different companies and all the different tools that are making data analysis tools and technologies easier for you, you're going to have a blast creating these insights with a lot less of the overhead that I had when I first started out. So I'm really excited to hear what you think and what your experience is going to be.
Welcome back. Now it's time to go even further and build on what you've learned about problem solving in data analytics and crafting effective questions. Coming up, we'll cover a wide range of topics. You'll learn about how data can empower our decisions, big and small, the difference between quantitative and qualitative analysis, and when to use them, the pros and cons of different data visualization tools, what metrics are and how analysts use them, and how to use mathematical thinking to connect the dots. To be honest, I'm still learning more about these things every day, and so will you. Like how quantitative and qualitative data can work together. In my role in finance, most of my work is quantitative. But recently, I was working on a project that focused a lot on empathy and trust, and that was really new for me. But we took those more qualitative things into account during analysis, and that really helped me understand how quantitative and qualitative data can come together to help us make powerful decisions. And now you're on your way to building your own data analyst toolkit. Before you know it, you'll be analyzing all kinds of data yourself and learning new things while you do it. But first, let's start small with the power of observation. We've talked a lot about what data is and how it plays into decision making. So what do we know already? Well, we know that data is a collection of facts. We also know that data analysis reveals important patterns and insights about that data. And finally, we know that data analysis can help us make more informed decisions. Now, we'll look at how data plays into the decision-making process and take a quick look at differences between data-driven and data-inspired decisions. Let's look at a real-life example. Think about the last time you searched restaurants near me and sorted the results by rating to help you decide which one looked best. That was a decision you made using data. Businesses and other organizations use data to make better decisions all the time. There's two ways they can do this, with data-driven or data-inspired decision-making. We'll talk more about data-inspired decision-making later on, but here's a quick definition for now. Data-inspired decision-making explores different data sources to find out what they have in common. Here at Google, we use data every single day, in very surprising ways too. For example, we use data to help cut back on the amount of energy spent cooling our data centers. After analyzing years of data collected with artificial intelligence, we were able to make decisions that help reduce the energy we use to cool our data centers by over 40%. Google's people operation team also uses data to improve how we hire new Googlers and how we get them started on the right foot. We wanted to make sure we weren't passing over any talented applicants and that we made their transition into their new roles as smooth as possible. So after analyzing data on applications, interviews, and new hire orientation processes, we started using an algorithm. An algorithm is a process or set of rules to be followed for a specific task. With this algorithm, we reviewed applicants that didn't pass the initial screening process to find great candidates. Data also helped us determine the ideal number of interviews that lead to the best possible hiring decisions. And we've created new onboarding agendas to help new employees get started at their new jobs. Data is everywhere. Today, we create so much data that scientists estimate 90% of the world's data has been created in just the last few years. Think of the potential here. The more data we have, the bigger the problems we can solve, and the more powerful our solutions can be. But responsibly gathering data is only part of the process. We also have to turn data into knowledge that helps us make better solutions. I'm going to let fellow Googler Ed talk more about that.
Just having tons of data isn't enough. We have to do something meaningful with it. Data in itself provides little value. To quote Jack Dorsey, the founder of Twitter and Square, every single action that we do in this world is triggering off some amount of data. And most of that data is meaningless until someone adds some interpretation of it, or someone adds a narrative around it. Data is straightforward. Facts collected together, values that describe something. Individual data points become more useful when they're collected and structured, but they're still somewhat meaningless by themselves. We need to interpret data to turn it into information. Look at Michael Phelps' time in a 200-meter individual medley swimming race. 1 minute, 54 seconds. Doesn't tell us much. When we compare it to his competitors' times in the race, however, we can see that Michael came in first place and won the gold medal. Our analysis took data, in this case a list of Michael's races and times, and turned it into information by comparing it with other data. Context is important. We needed to know that this race was an Olympic final and not some other random race, to determine that this was a gold medal finish. But this still isn't knowledge. When we consume information, understand it, and apply it, that's when data is most useful. In other words, Michael Phelps is a fast swimmer.
It's pretty cool how we can turn data into knowledge that helps us in all kinds of ways, whether it's finding the perfect restaurant or making environmentally friendly changes. But keep in mind, there are limitations to data analytics. Sometimes we don't have access to all of the data we need, or data is measured differently across programs, which can make it difficult to find concrete examples. We'll cover these more in details later on, but it's important to start thinking about them now. Now that you know how data drives decision-making, you know how key your role as a data analyst is to the business. Data is a powerful tool for decision-making, and you can help provide businesses with the information they need to solve problems and make new decisions. But before that, you'll need to learn a little more about the kinds of data you'll be working with and how to deal with it. Hi again. So, when it comes to decision making, data is key. But we've also learned that there are a lot of different kinds of questions that data might help us answer, and these different questions make different kinds of data. There are two kinds of data that we'll talk about in this video: quantitative and qualitative. Quantitative data is all about the specific and objective measures of numerical facts. This can often be the what, how many, and how often about a problem. In other words, things you can measure, like how many commuters take the train to work every week. As a financial analyst, I work with a lot of quantitative data. I love the certainty and accuracy of numbers. On the other hand, qualitative data describes subjective or explanatory measures of qualities and characteristics, or things that can't be measured with numerical data, like your hair color. Qualitative data is great for helping us answer why questions. For example, why people might like a certain celebrity or snack food more than others. With quantitative data, we can see numbers visualized as charts or graphs. Qualitative data can then give us a more high-level understanding of why the numbers are the way they are. This is important because it helps us add context to a problem. As a data analyst, you'll be using both quantitative and qualitative analysis, depending on your business task. Reviews are a great example of this. Think about a time you used reviews to decide whether you wanted to buy something or go somewhere. These reviews might have told you how many people dislike that thing and why. Businesses read these reviews too, but they use the data in different ways. Let's look at an example of a business using data from customer reviews to see qualitative and quantitative data in action. Now, say a local ice cream shop has started using their online reviews to engage with their customers and build their brand. These reviews give the ice cream shop insight into their customers' experiences, which they can use to inform their decision-making. The owner notices that their rating has been going down. He sees that lately his shop has been receiving more negative reviews. He wants to know why, so he starts asking questions. First are measurable questions. How many negative reviews are there? What's the average rating? How many of these reviews use the same keywords? These questions generate quantitative data, numerical results that help confirm their customers aren't satisfied. This data might lead them to ask different questions. Why are customers unsatisfied? How can we improve their experience? These are questions that lead to qualitative data. After looking through the reviews, the ice cream shop owner sees a pattern. 17 of negative reviews use the word frustrated. That's quantitative data. Now we can start collecting qualitative data by asking why this word is being repeated. He finds that customers are frustrated because the shop is running out of popular flavors before the end of the day. Knowing this, the ice cream shop can change its weekly order to make sure it has enough of what the customers want. With both quantitative and qualitative data, the ice cream shop owner was able to figure out his customers were unhappy and understand why. Having both types of data made it possible for him to make the right changes and improve his business. Now that you know the difference between quantitative and qualitative data, you know how to get different types of data by asking different questions. It's your job as a data detective to know which questions to ask to find the right solution. Then you can start thinking about cool and creative ways to help stakeholders better understand the data. For example, interactive dashboards, which we'll learn about soon. Data is great, but if we can't communicate the story data is telling, it isn't useful to anyone. So we need ways to organize data that helps us turn it into information. There are all kinds of tools out there to help you visualize and share your data analysis with stakeholders. Here, we'll talk about two kinds of data presentation tools, reports and dashboards. Reports and dashboards are both useful for data visualization, but there are pros and cons for each of them. A report is a static collection of data given to stakeholders periodically. A dashboard, on the other hand, monitors live incoming data. Let's talk about reports first. Reports are great for giving snapshots of high-level historical data for an organization. For example, a finance firm's monthly sales. Reports come with a lot of benefits too. They can be designed and sent out periodically, often on a weekly or monthly basis, as organized and easy to reference information. They're quick to design and easy to use as long as you continually maintain them. And finally, because reports use static data, or data that doesn't change once it's been recorded, they reflect data that's already been cleaned and sorted. There are some downsides to keep in mind too. Reports need regular maintenance and aren't very visually appealing. And because they aren't automatic or dynamic, reports don't show live evolving data. For a live reflection of incoming data, you'll want to design a dashboard. Dashboards are great for a lot of reasons. They give your team more access to information being recorded. You can interact with data by playing with filters. And because they're dynamic, they have long-term value. If stakeholders need to continually access information, a dashboard can be more efficient than having to pull reports over and over, which is a big time saver for you. And last but not least, they're just nice to look at. But dashboards do have some cons too. For one thing, they take a lot of time to design and can actually be less efficient than reports if they're not used very often. And if the base table breaks at any point, they need a lot of maintenance to get back up and running again. Dashboards can sometimes overwhelm people with information too. If you aren't used to looking through data on a dashboard, you might get lost in it. As a data analyst, you need to decide the best way to communicate information to your stakeholders. For example, what if your stakeholders are interested in the company's social media engagement? Would a monthly report that tells them the number of new followers for their page be useful? Or a dashboard that monitors live social media engagement across multiple platforms? Later on, you'll create your own reports and dashboards to practice using these tools. But for now, I want to show you what a report and a dashboard might look like. We'll start by using a tool we're already familiar with, spreadsheets. Let's see one way spreadsheet data could be visualized in a report. This spreadsheet has data set with order details from a wholesale company. That's a lot of information. From the headers, we can see different things recorded here, like the order date, the salesperson, the unit price, and revenue for each transaction recorded. It's all useful information, but a little hard to wrap your head around. We want a report that's easier to read. Let's say your stakeholders want a quick look at the revenue by salesperson. Using the data, you could make them a pivot table with a graph that shows that information. A pivot table is a data summarization tool that is used in data processing. Pivot tables are used to summarize, sort, reorganize, group, count, total, or average data stored in a database. It allows its users to transform columns into rows and rows into columns. We'll actually learn more about pivot tables later, but I'll show you one really quick. We'll select the Data menu and click Pivot Table button. It can pull data from this table, so we can just press Create and it'll pull up a new worksheet. Over here, it gives us the pivot table fields we can choose from. Let's select Salesperson and Revenue. And just like that, it made a chart for us. At this point, you can play around with how the graph looks, but the information is all there. Alright, let's move on to dashboards. If you need a more dynamic way to share information with your stakeholders, dashboards are your friend. You might create something like this Tableau dashboard, with interactive graphs that showcase multiple views of the data. With this, users can change location, date range, or any other aspect of the data they're viewing by clicking through different elements on the dashboard. Pretty cool, right? Later in this program, we'll look into how you can make your own data visualizations. We have a lot to learn before we get to that, but I hope this was an exciting first peek at the different visualization tools you'll be using as a data analyst. In the last video, we learned how you can visualize your data using reports and dashboards to show off your findings in interesting ways. In one of our examples, the company wanted to see the sales revenue of each salesperson. That specific measurement of data is done using metrics. Now, I want to tell you a little bit more about the difference between data and metrics and how metrics can be used to turn data into useful information. A metric is a single quantifiable type of data that can be used for measurement. Think of it this way. Data starts as a collection of raw facts until we organize them into individual metrics that represent a single type of data. Metrics can also be combined into formulas that you can plug your numerical data into. In our earlier sales revenue example, all that data doesn't mean much unless we use that specific metric to organize it. So let's use revenue by individual salesperson as our metric. Now we can see whose sales brought in the highest revenue. Metrics usually involve simple math. Revenue, for example, is the number of sales multiplied by the sales price. Choosing the right metric is key. Data contains a lot of raw details about the problem we're exploring, but we need the right metrics to get the answers we're looking for. Different industries will use all kinds of metrics to measure things in a data set. Let's look at some more ways businesses in different industries use metrics, so you can see how you might apply metrics to your collected data. Ever heard of ROI? Companies use this metric all the time. ROI, or return on investment, is essentially a formula designed using metrics that let a business know how well an investment is doing. The ROI is made up of two metrics, the net profit over a period of time and the cost of investment. By comparing these two metrics, profit and cost of investment, the company can analyze the data they have to see how well their investment is doing. This can then help them decide how to invest in the future and which investments to prioritize. We see metrics used in marketing too. For example, metrics can be used to help calculate customer retention rates or a company's ability to keep its customers over time. Customer retention rates can help the company compare the number of customers at the beginning and the end of a period to see their retention rates. This way, the company knows how successful their marketing strategies are and if they need to research new approaches to bring back more repeat customers. Different industries use all kinds of different metrics, but there's one thing they all have in common. They're all trying to meet a specific goal by measuring data. This metric goal is a measurable goal set by a company and evaluated using metrics. And just like there are a lot of possible metrics, there are lots of possible goals too. Maybe an organization wants to meet a certain number of monthly sales, or maybe a certain percentage of repeat customers. By using metrics to focus on individual aspects of your data, you can start to see the story your data is telling. Metric goals and formulas are great ways to measure and understand data, but they're not the only ways. We'll talk more about how to interpret and understand data throughout this course. So far, you've learned a lot about how to think like a data analyst. We've explored a few different ways of thinking, and now I want to take that one step further by using a mathematical approach to problem solving. Mathematical thinking is a powerful skill you can use to help you solve problems and see new solutions. So let's take some time to talk about what mathematical thinking is and how you can start using it. Using a mathematical approach doesn't mean you have to suddenly become a math whiz. It means looking at a problem and logically breaking it down step by step so you can see the relationship of patterns in your data and use that to analyze your problem. This kind of thinking can also help you figure out the best tools for analysis because it lets you see the different aspects of a problem and choose the best logical approach. There's a lot of factors to consider when choosing the most helpful tool for your analysis. One way you could decide which tool to use is by the size of your data set. When working with data, you'll find that there's big and small data. Small data can be really small. These kinds of data tend to be made up of data sets concerned with specific metrics over a short, well-defined period of time, like how much water you drink in a day. Small data can be useful for making day-to-day decisions, like deciding to drink more water, but it doesn't have a huge impact on bigger frameworks like business operations. You might use spreadsheets to organize and analyze smaller data sets when you first start out. Big data, on the other hand, has larger, less specific data sets covering a longer period of time. They usually have to be broken down to be analyzed. Big data is useful for looking at large-scale questions and problems, and they help companies make big decisions. When you're working with data on this larger scale, you might switch to SQL. Let's look at an example of how a data analyst working in a hospital might use mathematical thinking to solve a problem with the right tools. The hospital might find that they are having a problem with over or underuse of their beds. Based on that, the hospital could make bed optimization a goal. They want to make sure that beds are available to patients who need them, but not waste hospital resources like space or money on maintaining empty beds. Using mathematical thinking, you can break this problem down into a step-by-step process to help you find patterns in their data. There's a lot of variables in this scenario, but for now, let's keep it simple and focus on just a few key ones. There are metrics that are related to this problem that might show us pattern in the data. For example, maybe the number of beds open and the number of beds used over a period of time. There's actually already a formula for this. It's called the bed occupancy rate, and it's calculated using the total number of inpatient days and the total number of available beds over a given period of time. What we want to do now is take our key variables and see how their relationship to each other might show us patterns that can help the hospital make a decision. To do that, we have to choose the tool that makes sense for this task. Hospitals generate a lot of patient data over a long period of time, so logically, a tool that's capable of handling big data sets is a must. SQL is a great choice. In this case, you discover that the hospital always has unused beds. Knowing that, they can choose to get rid of some beds, which saves them space and money that they can use to buy and store protective equipment. By considering all of the individual parts of this problem logically, mathematical thinking helped us see new perspective that led us to a solution. Well, that's it for now. Great job. You've covered a lot of material already. You've learned about how empowering data can be in decision making, the difference between quantitative and qualitative analysis, using reports and dashboards for data visualization, metrics, and using a mathematical approach to problem solving. Coming up next, we'll be tackling spreadsheet basics. You'll get to put what you've learned into action and learn a new tool to help you along the data analysis process. See you soon. Hi again, I'm glad you're back. In this part of the program, we'll revisit the spreadsheet. Spreadsheets are a powerful and versatile tool, which is why they're a big part of pretty much everything we do as data analysts. There's a good chance a spreadsheet will be the first tool you reach for when trying to answer data-driven questions. So after you've defined what you need to do with the data, you'll turn to spreadsheets to help build evidence that you can then visualize and use to support your findings. Spreadsheets are often the unsung heroes of the data world. They don't always get the appreciation they deserve, but as a data detective, you'll definitely want them in your evidence collection kit. I know spreadsheets have saved the day for me more than once. I've added data for purchase orders into a sheet, set up formulas in one tab, and had the same formulas do the work for me in other tabs. This frees up time for me to work on other things during the day. I couldn't imagine not using spreadsheets. Math is a core part of every data analyst's job, but not every analyst enjoys it. Luckily, spreadsheets can make calculations more enjoyable, and by that I mean easier. Let's see how. Spreadsheets can do both basic and complex calculations automatically. Not only does this help you work more efficiently, but it also lets you see the results and understand how you got them. Here's a quick look at some of the functions that you'll use when performing calculations. Many functions can be used as part of a math formula as well. Functions and formulas also have other uses, and we'll take a look at those too. We'll take things one step further with exercises that use real data from databases. This is your chance to reorganize a spreadsheet, do some actual data analysis, and have some fun with data. Data analysts spend a lot of time organizing data and performing calculations. Luckily, there's lots of different tools to help them do just that, including spreadsheets. In this video, we'll take a look at some of the ways data analysts use spreadsheets to help them with their day-to-day responsibilities. Later, you'll get to test out some of these things yourself. But for now, let's start with a quick look at how data analysts use spreadsheets to do their jobs. This will change depending on the work you need to complete, but here's an overview of a few of the major tasks. Imagine you work for a construction company. Your company needs your spreadsheet skills to analyze some data about their expenses. So you access the appropriate data and add it to your spreadsheet. We won't cover all the details of this project right now, but you will get a chance to see lots of spreadsheet features up close and personal as we move forward. What do you do with the data now that it's in your spreadsheet? Again, this will be different for each job, but you might start by organizing your data with the task you've been given. For example, you might put your data in a pivot table. We've talked about pivot tables before in this course. We'll cover them in more detail later on, but for now, just think of them as a well-organized and very useful tables. Next, you might filter the data in the pivot table. Sorting and filtering data is a common part of most jobs. This lets you focus only on the data you'll need for your analysis. In our example, maybe you only need the expenses for a certain time frame, like the last 3 months. After you've filtered your data, you could perform some calculations to learn more about it. Maybe you need to find out which construction projects ended up costing the most money. This is where formulas and functions are really handy. We'll talk about them in just a bit, but formulas and functions are great for doing some quick math, especially once you run out of fingers and toes to count on. Now you've seen some of the ways data analysts are using spreadsheets in their day-to-day work for a lot of different tasks, including organizing their data and making calculations. Before you know it, we'll have you working in your own spreadsheets.
Welcome to Qwiklabs. Now it's time to get hands-on practice on a lot of the amazing data analyst concepts that you've learned so far. Here's where you get to prove that you've learned some great technologies, and then you'll get credit for it back inside of Coursera. But before you jump right in, let me just give you a quick walkthrough of what a Qwiklab is, and then we'll get started. First and foremost, in the upper left-hand corner, you notice a gigantic tempting button called Start Lab in green. I want to go ahead and start that. Click this box that says I'm not a robot. select a few of the different items for your captures. You can see this is the hardest part of the lab, is trying to actually get through the anti-robot technology that they have here. Now, a couple things happen in the background. As author of these labs, this is some of our best work that we're getting you hands-on practice for. And what we're going to do next is just make sure that that timer starts counting down, because then that's going to give you the account logins that you need to practice the work inside of the lab. Now, here's what you're going to do. There's going to be a gigantic big button that says Open Google Cloud Console. I want you to go ahead and click on that. And now you have 3 browser tab windows open, or 100 if you're like me. And in the second browser, this is your Qwiklabs login. All the way under username, what I want you to do is copy that username. And here's the #1 mistake that I've seen students make. When you're back into Google, everyone sees this Google sign-in screen here, and they immediately start typing in their personal Gmail address. You don't want to be charged for any of the resources that you're going to be using. That's why we're providing you with this Qwiklabs account yourself. And all I'm going to do is paste in the email that's been given to me by the Qwiklab for use for an hour, and then click Next. And then I'm going to go ahead and grab the password, paste that in here, and then you're going to see a bunch of terms and conditions because this is a brand new account. Scroll through the terms and conditions, read them at your leisure, click Accept. And as you work through the terms of service here, eventually you'll land on the homepage for Google Cloud. Scroll down, read the terms of service, accept terms of service. All the steps that I'm walking you through right now are also available inside of the lab written instructions as well. So once you've gotten that out of the way, let's take a look at what this particular Qwiklab is going to teach you. At a high level, I'm not going to do the lab for you, but don't worry, it's step by step. You'll have a blast doing it. And you have way more than enough time you need in this timer before your lab timer runs out. Generally, as lab authors, we try to double the budget of allowed time, so don't worry about lab timeouts. So inside the lab, every lab will start with an overview, and then what specifically it is that you're going to do. Inside of this lab, since you're a data analyst, you're going to be creating spreadsheets and adding files and sharing files with some of your other data analysts. If you forget what section you're in, another pro tip that I like to do is, on the right-hand side, you can actually click between each of the different header sections right here as I'm doing now, and you can jump to a particular section inside of the workbook. So say you and your friends are working on this together, you can say, hey, I'm having trouble on the share and collaborate section. You can just click on that and it'll jump right to that section. Well, that's pretty much it. A few more housekeeping items and then you're off to the races. As you work your way through the lab, you want to make sure that you're completing the objectives and making sure that you're staying on track. There is intelligence built into the Qwiklabs to prevent any kind of behavior that's not part of the lab. So make sure you're following the lab as is. And when you're done with the lab, say I was completed here, all you have to do is click on End Lab, click on OK, and that's going to bring you to a pop-up screen that asks you to rate the lab, add in any comments for the lab authors like me, submit it, and then automatically your score for the work that you've done in the lab is fed back to Coursera, which is pretty cool. And that's it. That was a quick tour of Qwiklabs, about 5 minutes, but honestly, you'll have a blast going through these. Good luck.
We've talked about how spreadsheets are great for organizing data and performing calculations. Now it's time to get our hands dirty and start building a real spreadsheet. In this video, I'm going to demonstrate some basic tasks we know data analysts use spreadsheets for, including entering and organizing data. We'll start with a step-by-step process to show you some tools to organize your data in a spreadsheet. Consider these steps the basics. You won't always have to use them when working with a data set, but if your data is a bit messy when you get it, these steps can help you get it ready for analysis. Let's start by opening a new spreadsheet. As a data analyst, you might not start with a blank spreadsheet, but it's good to know how to do it, just in case. Start by opening Excel, Google Sheets, or whatever spreadsheet software you're using. Then, select a new blank file. The first thing you'll want to do when you open a new spreadsheet is give it a title. Here's a pro tip. Make your title short, clear, and have it state exactly what the data in the spreadsheet is about. Trust me, it'll make searching for it a lot easier. Creating a folder on your computer specifically for spreadsheets and related files can also make it easier to find them. For this spreadsheet, it's already saved in our drive, so we'll open our File menu to click Move. Then we'll create a new folder. Name it population data. And move the spreadsheet there. Our spreadsheet now has a new home. This will save you a lot of unnecessary clicks and headaches when you look for this file. There's a few different ways data analysts get data they work with. Depending on the job, you might use data from an open source. You might be given data to work with, or you might be asked to find your own data. You'll experience all of these later in the program. There's a lot of open data sources online where data is made available to the public. For example, we'll use data from worldbank.org that's already in a spreadsheet. The data shows the population of Latin American and Caribbean countries from 2010 through 2019. Let's open this spreadsheet. Okay, time to get the data ready for analysis. We'll start by selecting the whole sheet and making our columns wider by dragging the boundary of one of the columns. This will help us see the data clearly. Then we can adjust any individual columns that need it. You can make columns wider in other ways as well, but this will work for now. The first row of the spreadsheet is for data attributes, or variables, so it's basically labeling the type of data in each column. Let's make the attributes stand out from the rest of the rows by selecting it and filling it with color. We'll also make the labels bold. If we want to add another data attribute between two of the other attributes, we can always add a new column. Just click on any cell within a column and use the Insert menu to add a new one. It will appear next to the column you originally clicked. Pretty simple, right? Deleting a column is just as simple. To delete, right-click in a cell in the column you want to get rid of. The steps we're showing may be different depending on the spreadsheet program you're using, but should be pretty similar. Let's add one more thing to our data table, borders. This can help you see each piece of data more clearly. To add borders, start by clicking the Select All button at the top left corner of your spreadsheet. This is kind of like a magic button because you can click it whenever you need to make changes to every cell in your spreadsheet. Then click the border button in the menu and choose the type of borders you want. To keep our spreadsheets uniform, we'll choose borders for all cells. And just like that, we've gone from raw to refined. Now our spreadsheet is filled with data, and it's nice to look at too. Using these organization tools before you analyze can help you focus on the data once you start your analysis. Now that we've gone over some ways spreadsheets can be used to organize data, you're ready to start working on them yourself. Later, you'll learn more about spreadsheets, including some common errors and how to fix them. So far, we've covered how to start a new spreadsheet, enter in data, and make it look refined and ready for some serious analysis. Now we'll learn how to perform calculations in your spreadsheet. You may need to calculate everything from sums to averages to finding minimums and maximum amounts. You'll use calculations for a lot of different kinds of tasks. So in this video, we'll focus on learning the basics and then do a little math with some sales data to practice. Let's talk about formulas first. You might remember that a formula is a set of instructions that perform a specific calculation. Basically, formulas can do the math for you. Now, they don't only do math, they can do a lot more. And soon you'll learn different ways you can use them throughout the data analysis processes. Formulas are built on operators, which are symbols that name the type of operation or calculation to be performed. For example, a plus sign is a common operator. The formulas you use as a data analyst will usually include at least one operator. Now let's talk about math expressions or equations. These can take a lot of different forms, but you might be familiar with them already. 3 minus 1, 15 plus 8 divided by 2, 846 times 513. These are all examples of expressions. Is this bringing back memories of grade school? Well, back in math class, you most likely learned to complete an expression by including an equal sign and the solution. It's slightly different with spreadsheets. When you create a formula using an expression in a spreadsheet, you start the formula with an equal sign. For example, if we want to subtract, we type an equal sign followed by the rest of the expression without any spaces in the formula. Now let's try an expression that's a bit more challenging. We'll type 31982, then a hyphen for a minus sign, then 17795. And to calculate, we press enter. You'll most likely use formulas this way when dealing with large numbers or expressions with multiple steps. Here are the operators you'll use to complete formulas: the plus sign for addition, the minus or hyphen for subtraction, the asterisk for multiplication, and the / for division. The division and multiplication symbols might be different than what you're used to. Small changes, but important to keep in mind. If you already have data in your spreadsheet, you can use cell references in your formulas instead. A cell reference is a single cell or range of cells in a worksheet that can be used in a formula. Cell references contain the letter of the column and the number of the row where the data is. A range of cells is a collection of 2 or more cells. A range can include cells from the same row or column or from different columns and rows collected together. We'll show you an example in an upcoming video. Now let's apply what we just learned to some sales data. If we want to add these figures to find the total sales for the first row of data, you can click cell F2. From there, we'll start with an equal sign and use the cell references to input values in your expression. We're starting with cell B2 because the year in A2 is not a value we want to add to the total. Then press enter. And just like that, your total sales has been calculated for you. But what if you realized one of the values in your data was wrong? No problem. You can change the value in any cell used in the formula and the total will update automatically. The great thing about using cell references is that they also automatically update when a formula is copied to a new cell. Talk about a time saver. So instead of entering the same formula again for every new set of cell references, just copy the formula using the menu or a keyboard shortcut like Ctrl+C. Then paste the formula where you want to apply it using Ctrl+V. And presto, the formula updates all the new cells and values correctly. Now, let's say you also wanted to find the average sales. For this, you create a new formula in a different cell. To group values in a formula, use parentheses. This lets your spreadsheet know which values to calculate together and the order of the operations to be performed. For example, open parentheses, then B2 plus C2 plus D2 plus E2, and close parentheses. Then divide the value of all of this by 4 by typing /4. So you are adding the values in the 4 cells together and then using the slash to divide the total by 4. And just like the last one, we can copy and paste the formula. Here's another formula you can use if you want to find the % change in sales between June and July. Once the formula calculates the value, you can then use the % button to change the value to a percentage. When you apply the formula to the other rows, both the formula and the % will automatically update. Uh-oh, that doesn't look like the right answer. Looks like we've got an error. Don't worry, errors can happen at any stage of data analysis, and that includes when you're using spreadsheets. A formula has to be airtight. If there's something wrong with one of the cell references, it won't work. So what's our error? Well, we can see that the value in cell D4 is missing. It might take some time and research on your part to find the correct value, but it's worth it. You want your analysis to be as accurate as possible. When you do add the value, the formula takes care of the rest. That was a lot to take in. Thanks for staying with me. You'll be able to apply what you learned about formulas here and later in the program to make your analysis more efficient and your job a little easier. And soon, you'll work in your own spreadsheet. Happy spreadsheeting! Formulas are a great way to become more efficient when using spreadsheets, especially when you add shortcuts like copying and pasting into the mix. As you progress as a data analyst, you'll most likely learn more shortcuts to help your process. But now it's time to move on to functions. While they're closely related to formulas, they're not exactly the same. By the end of this video, you'll understand the difference and know when to use them both. In the world of spreadsheets, a function is a preset command that automatically performs a specific process or task using the data. You might remember some of the shortcuts we learned that can be used with formulas. Think of functions as the most useful of these shortcuts. The good news is a lot of spreadsheet functions have names that tell you what they do. There are tons of functions out there, and as you continue to work with spreadsheets, you'll find that you use certain ones a lot and others rarely or not at all. For now, let's take a look at some of the functions that we can apply to our sales data from the previous video. We'll start with total sales. Let's use the sum function for this in cell F2. The first steps are pretty similar to what we did in the last video. First, we'll select the cell where we want the calculation to appear, type equals, then add the word sum as our function. One of the great things about functions is they don't always need operators, like a plus sign for addition. In this case, after the open parentheses, you can go ahead and select the range of cells you're adding. A colon between the cell references shows that you're using a range. In this case, the range includes cells from the same row. After the close parentheses, we press enter, and just like that, our total sales number appears. Just like the formula we used before, functions can be copied and pasted into other cells in the same column. But let's undo that step so that you can see another way to copy a function or formula. Spreadsheets have something called a fill handle. It's a little box that appears in the lower right-hand corner when you click on a cell. If you rest your cursor on the box, you can then drag the fill handle to the other boxes in the same row or column. Any formula or function in that cell will automatically be added to the cells you fill. Plus, the fill handle will update the formula so the cell references match the row of the columns of the cells you fill. This means the formula is calculated based on the data in each separate row or column. Filling won't work for every situation, but it's still a pretty great trick. Now, let's find the average sale for each month using the average function. Different functions perform different calculations, but they work in the same way. Keep in mind, not every calculation you'll come across has its own function to help you. For example, to find the percent change in sales between June and July, you'd use the same formula you used in an earlier video. Let's say you're asked to find the lowest monthly sales in this dataset. There is a function for that. It's called the min function, which stands for minimum. Here's how it works. Say you need to find the lowest monthly sales for the whole set. All you have to do is set up the function. Then, after the open parentheses, select the values from all three rows. This might be important information for your stakeholders, so let's add color to the cell with that value in your dataset to make it stand out. In this case, click on cell D2 and then fill color icon, which looks like a paint can. Then choose a color. I'll use yellow here. You can follow the same steps for the highest sales by using the, wait for it, max function. Looks like we have an error message. What could be wrong? We forgot to include an open parentheses after the function. No worries, it's a quick fix. But this is a good reminder to continually check the format of your functions and formulas as you use them. We'll learn more about error messages and how to work with them later. Okay, that's better. Now we'll add color to the cell with the highest sales too. This is just one way to highlight key data. You'll find out about some others later. You've now had a peek at some ways you can add and organize data in a spreadsheet. You've also seen how powerful formulas and functions can be when applied to real-world data. As a data analyst, this is just the beginning of your experience with spreadsheets. You'll soon find out how much more spreadsheets have to offer. In the meantime, you're free to practice some of these formulas, functions, and other processes on your own. It can be fun to experiment and see all that spreadsheets can do. Soon, you'll switch from spreadsheets to structured thinking. The data analytics pieces are starting to fit together. Exciting stuff is coming right up, so stick around.
Welcome to Qwiklabs. Now it's time to get hands-on practice on a lot of the amazing data analyst concepts that you've learned so far. Here's where you get to prove that you've learned some great technologies, and then you'll get credit for it back inside of Coursera. But before you jump right in, let me just give you a quick walkthrough of what a Qwiklab is, and then we'll get started. First and foremost, in the upper left-hand corner, you notice a gigantic tempting button called Start Lab in green. I want to go ahead and start that. Click this box that says I'm not a robot. Select a few of the different items for captures. You can see this is the hardest part of the lab, is trying to actually get through the anti-robot technology that they have here. Now, a couple things happen in the background. As author of these labs, this is some of our best work that we're getting you hands-on practice for. And what we're going to do next is just make sure that that timer starts counting down, because then that's going to give you the account logins that you need to practice the work inside of the lab. Now, here's what you're going to do. There's going to be a gigantic big button that says Open Google Cloud Console. I want you to go ahead and click on that. And now you have 3 browser tab windows open, or 100 if you're like me. And in the second browser, this is your Qwiklabs login. All the way under username, what I want you to do is copy that username. And here's the number one mistake that I've seen students make. When you're back into Google, everyone sees this Google sign-in screen here, and they immediately start typing in their personal Gmail address. You don't want to be charged for any of the resources that you're going to be using. That's why we're providing you with this Qwiklabs account yourself. And all I'm going to do is paste in the email that's been given to me by the Qwiklab for use for an hour, and then click Next. And then I'm going to go ahead and grab the password, paste that in here, and then you're going to see a bunch of terms and conditions because this is a brand new account. Scroll through the terms and conditions, read them at your leisure, click Accept. And as you work through the terms of service here, eventually you'll land on the homepage for Google Cloud. Scroll down, read the terms of service, accept terms of service. All the steps that I'm walking you through right now are also available inside of the lab written instructions as well. So once you've gotten that out of the way, let's take a look at what this particular Qwiklab is going to teach you. At a high level, I'm not going to do the lab for you, but don't worry, it's step by step. You'll have a blast doing it. And you have way more than enough time you need in this timer before your lab timer runs out. Generally, as lab authors, we try to double the budget of allowed time, so don't worry about lab timeouts. So inside the lab, every lab will start with an overview, and then what specifically it is that you're going to do. Inside of this lab, since you're a data analyst, you're going to be creating spreadsheets and adding files and sharing files with some of your other data analysts. If you forget what section you're in, Another pro tip that I like to do is on the right-hand side, you can actually click between each of the different header sections right here as I'm doing now, and you can jump to a particular section inside of the workbook. So say you and your friends are working on this together, you can say, hey, I'm having trouble on the share and collaborate section. You can just click on that and it'll jump right to that section. Well, that's pretty much it. A few more housekeeping items and then you're off to the races. As you work your way through the lab, you want to make sure that you're completing the objectives and making sure that you're staying on track. There is intelligence built into the Qwiklabs to prevent any kind of behavior that's not part of the lab. So make sure you're following the lab as is. And when you're done with the lab, say I was completed here, all you have to do is click on End Lab, click on OK, and that's going to bring you to a pop-up screen that asks you to rate the lab, add in any comments for the lab authors like me, submit it, and then automatically your score for the work that you've done in the lab is fed back to Coursera, which is pretty cool. And that's it. That was a quick tour of Qwiklabs, about 5 minutes, but honestly, you'll have a blast going through these. Good luck.
Albert Einstein once said, if I were given 1 hour to save the planet, I would spend 59 minutes defining the problem and 1 minute resolving it. Now, that might seem extreme, but it does show us just how important it is to define the problems before trying to solve them. A lot of times, teams jump right into data analysis before realizing a few months later that they are either solving the wrong problem or they don't have the right data. In this video, we will learn how to develop a structured approach to defining the problem domain. This is important because if you define the problem clearly from the start, it'll be easier to solve, which saves a lot of time, money, and resources. In the data world, we call this first piece the problem domain, the specific area of analysis that encompasses every activity affecting or affected by the problem. Before we can do anything else, we need to understand the problem domain and all of its parts and relationships so that we can discover the whole story. Actually, calling it the first piece makes me think of a jigsaw puzzle. Say you have a puzzle. Let's think of that puzzle as our problem domain. You have all 500 pieces, but you lost the box, so you don't know what the image the puzzle will reveal. Will it be an animal, a waterfall, a bowl of oranges? Whatever it is, it's going to be tough trying to put it together without an image you can refer to. Even the greatest puzzler in the galaxy would need a new process and lots of time to complete that puzzle. Data analysts face the same kinds of challenges too. You might remember that data analysts aren't always given the complete picture at the start of a project. A big part of their job is to develop a structured approach and use critical thinking to find the best solution. And that starts with understanding the problem domain. This is where structured thinking comes into play. To successfully solve a problem as a data analyst, you need to train your brain to think structurally. And that's exactly what you'll learn coming up. See you there. So, earlier I told you that carefully defining a business problem can ultimately save time, money, and resources. All of this is achieved through structured thinking. Structured thinking is the process of recognizing the current problem or situation, organizing available information, revealing gaps and opportunities, and identifying the options. In other words, it's a way of being super prepared. It's having a clear list of what you are expected to deliver, a timeline for major tasks and activities, and checkpoints so the team knows you're making progress. In this video, we'll look at how structured thinking helps us save time and effort, but also makes our job as data analysts easier because it allows us to better understand the work we are doing. In the business world, it's common for teams to spend hours of valuable time trying to solve an important problem, only to end up back where they started. Not only is the initial problem not resolved, but they've spent hours not resolving it. This outcome negatively affects you, your team, and the organization as a whole. But it can usually be prevented. Many times the situation is a result of not fully understanding the issue. Structured thinking will help you understand problems at a high level so that you can identify areas that need deeper investigation and understanding. The starting place for structured thinking is the problem domain, which you might have remembered from earlier. Once you know the specific area of analysis, you can set your base and lay out all your requirements and hypotheses before you start investigating. With a solid base in place, you'll be ready to deal with any obstacles that come up. What kind of obstacles? Well, let's say you're asked to predict the future value of an apartment building based on a given data set. You have hundreds of variables, and every one is crucial to your analysis. But what if one variable accidentally gets left out, like square footage, for example? You'd have to go back and redo all your hard work. That's because missing variables can lead to inaccurate conclusions. Another way that you can practice structured thinking and avoid mistakes is by using a scope of work. A scope of work, or SOW, is an agreed upon outline of the work you're going to perform on a project. For many businesses, this includes things like work details, schedules, and reports that the client can expect. Now, as a data analyst, your scope of work will be a bit more technical. It'll include those basic items we just mentioned, but you'll also focus on things like data preparation, validation, analysis of quantitative and qualitative data sets, initial results, and maybe even some visuals to really get the point across. Let's bring a scope of work to life with a simple example. Say a couple has hired a wedding planner. We'll focus on just one task, the wedding invitations. Here's what might be in scope of work: deliverables, timeline, milestones, and reports. Let's break down just one of these, deliverables. The wedding planner and couple will need to decide on the invitation, make a list of people to invite, collect their addresses, print the invitations, address the envelopes, stamp them, and mail them out. Now let's check out the timelines. You'll notice the dates and the milestones, which keep us on track. Finally, we have the reports, which give our couple some peace of mind by telling them when each stop is complete. A scope of work can be a simple but powerful tool. With a solid scope of work, you'll be able to address any confusion, contradictions, or questions about the data up front and make sure these sneaky setbacks don't stand in your way. This is a simple example of what a scope of work might look like, but later you'll be able to practice building your own. Next up in our scope, we'll check out setbacks from a different angle by learning the importance of contextualizing data and avoiding bias. Looking forward to sharing some cool insights with you. Welcome back. In this video, we'll explore the importance of contextualizing data and recognizing data bias. Let's get started. Data doesn't live in a vacuum. It needs context. Earlier, we learned that context is the condition in which something exists or happens. So actions can be appropriate in some contexts but inappropriate in others. For example, yelling "move" is rude in one context, like if your friend is standing in front of the TV, but it's entirely appropriate in another, like if that friend is about to get hit by a kid on a tricycle. Do you see the difference? In the world of data, numbers don't mean much without context. I'll let my fellow Googler, Ed, tell you a little bit more about that.
As we have more and more data available to us, we can leverage that data in increasingly sophisticated ways and generate more powerful insights from it. We use data at many different levels. Sometimes our data is descriptive, answering questions like, how much did we spend on travel last month? Data becomes more valuable as we generate diagnostic and predictive insights, like understanding why travel spend increased last month. Data is most valuable, however, when we can generate prescriptive insights. For example, how can we leverage data to incentivize more efficient travel?
Figuring out what data means is just as important as collecting it. As a data analyst, a big part of your job is putting data into context. It's also up to you to remain objective and recognize all sides of an argument before drawing conclusions. The thing about context is that it's very personal. If two people curate the same data set and follow the same directions, there's a chance they will end up with different results. Why? Because there is no universal set of contextual interpretations. Everyone approaches it in their own way. And even if the data collection process is correct, the analysis can still be misinterpreted. Conclusions can be influenced by your own conscious and subconscious biases, which are based on cultural, social, and market norms. For example, if you ask a Boston resident which baseball team is the best, chances are they're going to say Boston Red Sox, which brings us to a major limitation of data analytics. If the analysis is not objective, the conclusions can be misleading. To really understand what the data is about, you have to think through who, what, where, when, how, and why. It's good to ask yourself questions like, who collected the data, and what is it about? What does the data represent in the world, and how does it relate to other data? When was the data collected? Data collected a while ago may have certain limitations given the present-day situation. For example, if we collected phone numbers over the past century, at some point mobile phones would have been introduced, leading to the need for an additional phone number field. You should also think about where was the data collected. A lot can change across cities, states, and countries. And how was it collected? A survey might not be as effective as an in-person interview, for example. And of course, there's the why. The why can have a particularly strong relationship with bias. Why? Because sometimes data is collected or even made up to serve an agenda. The best thing you can do for the fairness and accuracy of your data is to make sure you start with an accurate representation of the population and collect the data in the most appropriate and objective way. Then you'll have the facts that you can pass on to your team. Hopefully, you now understand the importance of fair and objective data and how important context is when it comes to understanding and interpreting it. Next up, we'll figure out how we can bring it to life. Hey, welcome back! So far, you've learned about things like spreadsheets, analytical thinking skills, metrics, and mathematics. These are all super important technical skills that you'll build on throughout your data analytics career. You should also keep in mind that there are some non-technical skills that you can use to create a positive and productive working environment. These skills will help you consider the way you interact with your colleagues as well as your stakeholders. We already know that it's important to keep your team members and stakeholders' needs in mind. Coming up, we'll talk about why that is, and we'll start learning some communication best practices you can use in your day-to-day work. Remember, communication is key. We'll start by learning all about effective communication and how to balance team member and stakeholder needs. Think of these skills as new tools that'll help you work with your team to find the best possible solutions. Alright, let's head on to the next video and get started. As a data analyst, you'll be required to focus on a lot of different things, and your stakeholders' expectations are one of the most important. We're going to talk about why stakeholder expectations are so important to your work and look at some examples of stakeholder needs on a project. By now you've heard me use the term stakeholder a lot, so let's refresh ourselves on what a stakeholder is. Stakeholders are people that have invested time, interest, and resources into the projects that you'll be working on as a data analyst. In other words, they hold stakes in what you're doing. There's a good chance they'll need the work you do to perform their own needs. That's why it's so important to make sure your work lines up with their needs, and why you need to communicate effectively with all of the stakeholders across your team. Your stakeholders will want to discuss things like the project objective, what you need to reach that goal, and any challenges or concerns you have. This is a good thing. These conversations help build trust and confidence in your work. Here's an example of a project with multiple team members. Let's explore what they might need from you at different levels to reach the project's goal. Imagine you're a data analyst working with a company's human resources department. The company has experienced an increase in its turnover rate, which is the rate at which employees leave a company. The company's HR department wants to know why that is, and they want you to help them figure out potential solutions. The vice president of HR at this company is interested in identifying any shared patterns across employees who quit and seeing if there's a connection to employee productivity and engagement. As a data analyst, it's your job to focus on the HR department's question and to help find them an answer. But the BP might be too busy to manage day-to-day tasks or might not be your direct contact. For this task, you'll be updating the project manager more regularly. Project managers are in charge of planning and executing a project. Part of the project manager's job is keeping the project on track and overseeing the progress of the entire team. In most cases, you'll need to give them regular updates. Let them know what you need to succeed and tell them if you have any problems along the way. You might also be working with other team members. For example, HR administrators will need to know the metrics you're using so that they can design ways to effectively gather employee data. You might even be working with other data analysts who are covering different aspects of the data. It's so important that you know who the stakeholders and other team members are in a project so that you can communicate with them effectively and give them what they need to move forward in their own roles on the project. You're all working together to give the company vital insights into this problem. So back to our example. By analyzing company data, you see a decrease in employee engagement and performance after their first 13 months at the company, which could mean that employees started feeling demotivated or disconnected from their work, and then often quit a few months later. Another analyst who focuses on hiring data also shares that the company had a large increase in hiring around 18 months ago. You communicate this information with all your team members and stakeholders, and they provide feedback on how to share this information with your VP. In the end, your VP decides to implement an in-depth manager check-in with employees who are about to hit their 12-month mark at the firm to identify career growth opportunities, which reduces the employee turnover starting at the 13-month mark. This is just one example of how you might balance needs and expectations across your team. You'll find that in pretty much every project you work on as a data analyst, different people on your team, from the VP of HR to your fellow data analysts, will need all your focus and communication to carry the project to success. Focusing on stakeholder expectations will help you understand the goal of a project, communicate more effectively across your team, and build trust in your work. Coming up, we'll discuss how to figure out where you fit on your team and how you can help move a project forward with focus and determination. So now that we know the importance of finding the balance across your stakeholders and your team members, I want to talk about the importance of staying focused on the objective. This can be tricky when you find yourself working with a lot of people with competing needs and opinions. But by asking yourself a few simple questions at the beginning of each task, you can ensure that you're able to stay focused on your objective while still balancing stakeholder needs. Let's think about our employee turnover example from the last video. There, we were dealing with a lot of different team members and stakeholders, like managers, administrators, even other analysts. As a data analyst, you'll find that balancing everyone's need can be a little chaotic sometimes. But part of your job is to look past the clutter and stay focused on the objective. It's important to concentrate on what matters and not get distracted. As a data analyst, you could be working on multiple projects with lots of different people. But no matter what project you're working on, there are 3 things you can focus on that will help you stay on task. 1, who are the primary and secondary stakeholders? 2, who is managing the data? And 3, where can you go for help? Let's see if we can apply those questions to our example project. The first question you can ask is about who the stakeholders are. the primary stakeholder of this project is probably the vice president of HR who's hoping to use this project's findings to make new decisions about company policy. You'd also be giving updates to your project manager, team members, or other data analysts who are depending on your work for their own task. These are your secondary stakeholders. Take time at the beginning of every project to identify your stakeholders and their goals. Then, see who else is on your team and what their roles are. Next, you'll want to ask who's managing the data. For example, think about working with other analysts on this project. You're all data analysts, but you may manage different data within your project. In our example, there was another data analyst who was focused on managing the company's hiring data. Their insights around search and new hires 18 months ago turned out to be a key part of your analysis. If you hadn't communicated with this person, you might have spent a lot of time trying to collect or analyze hiring data yourself. Or you may not have even been able to include it in your analysis at all. Instead, you were able to communicate your objectives with another data analyst and use existing work to make your analysis richer. By understanding who's managing the data, you can spend your time more productively. Next up, you need to know where you can go when you need help. This is something you should know at the beginning of any project you work on. If you run into bumps in the road on your way to completing a task, you need someone who is best positioned to take down those barriers for you. When you know who's able to help, you'll spend less time worrying about other aspects of the project and more time focused on the objective. So, who could you go to if you ran into a problem on this project? Project managers support you and your work by managing the project timeline, providing guidance and resources, and setting up efficient workflows. They have a big picture view of the project because they know what you and the rest of the team are doing. This makes them a great resource if you run into a problem. In the employee turnover example, you would need to be able to access employee departure survey data to include in your analysis. If you're having trouble getting approvals for that access, you can speak with your project manager to remove those barriers for you so that you can move forward with your project. Your team depends on you to stay focused on your task, so that as a team, you can find solutions. By asking yourself 3 easy questions at the beginning of new projects, you'll be able to address stakeholder needs, feel confident about who is managing the data, and get help when you need it, so that you can keep your eyes on the prize, the project objective. So far, we've covered the importance of working effectively on a team while maintaining your focus on stakeholder needs. Coming up, we'll go over some practical ways to become better communicators so that we can help make sure the team reaches its goals. Welcome back! We've talked a lot about understanding your stakeholders and your team so that you can balance their needs and maintain a clear focus on your project objectives. A big part of that is building good relationships with the people you're working with. And how do you do that? 2 words: clear communication. Now we're going to learn about the importance of clear communication with your stakeholders and team members, and start thinking about who you'll want to communicate with and when. First, it might help to think about communication challenges you might already experience in your daily life. Have you ever been in the middle of telling a really funny joke only to find out your friend already knows the punchline? Or maybe they just didn't get what was funny about it? This happens all the time, especially if you don't know your audience. This kind of thing can happen at the workplace too. Here's a secret to effective communication. Before you put together a presentation, send an email, or even tell that hilarious joke to your coworker, think about who your audience is, what they already know, what they need to know, and how you can communicate that effectively to them. When you start by thinking about your audience, they'll know it and appreciate the time you took to consider them and their needs. Let's say you're working on a big project analyzing annual sales data and you discover that all of the online sales data is missing. This could affect your whole team and significantly delay the project. By thinking through these 4 questions, you can map out the best way to communicate across your team about this problem. First, you'll need to think about who your audience is. In this case, you'll want to connect with other data analysts working on the project, as well as your project manager, and eventually the VP of Sales, who is your stakeholder. Next up, you'll think through what this group already knows. The other data analysts working on this project know all the details about which data set you are using already. And your project manager knows the timeline you're working towards. Finally, the VP of Sales knows the high-level goals of the project. Then, you'll ask yourself what they need to know to move forward. Your fellow data analysts need to know the details of what you have tried so far and any potential solutions you've come up with. Your project manager would need to know the different teams that could be affected and the implications for the project, especially if this problem changes the timeline. Finally, the VP of Sales will need to know that there's a potential issue that would delay or affect the project. Now that you've decided who needs to know what, you can choose the best way to communicate with them. Instead of a long, worried email which could lead to lots back and forth, you decide to quickly book in a meeting with your project manager and fellow analysts. In the meeting, you let the team know about the missing online sales data and give them more background info. Together, you discuss how this impacts other parts of the project. As a team, you come up with a plan and update the project timeline if needed. In this case, the VP of Sales didn't need to be invited to your meeting, but would appreciate an email update if there were changes to the timeline, which your project manager might send along herself. When you communicate thoughtfully and think about your audience first, you'll build better relationships and trust with your team members and stakeholders. And that's important because those relationships are key to the project's success, and your own too. So, when you're getting ready to send an email, organize a meeting, or put together a presentation, think about who your audience is, what they already know, what they need to know, and how you can communicate that effectively to them. Next up, we'll talk more about communicating at work, and you'll learn some useful tips to make sure you get your message across clearly. No matter where you work, you'll probably need to communicate with other people as part of your day-to-day job. Every organization and every team in that organization will have different expectations for communication. Coming up, we'll learn some practical ways to help you adapt to those different expectations and some things that you can carry over from team to team. Let's get started. When you start at a new job or a new project, you might find yourself feeling a little out of sync with the rest of your team and how they communicate. That's totally normal. You'll figure things out in no time if you're willing to learn as you go and ask questions when you aren't sure of something. For example, if you find your team uses acronyms you aren't familiar with, don't be afraid to ask what they mean. When I first started at Google, I had no idea what TLDR meant, and I was always seeing it at the top of emails. Well, I learned it stands for Too Long Didn't Read, and I use it all the time now if I need to give someone a quick summary at the beginning of a long email. That was one of the many acronyms I've learned, and I come across new ones all the time, so I'm never afraid to ask. Every work setting has some form of etiquette. Maybe your team members appreciate eye contact and a firm handshake, or it might be more polite to bow, especially if you find yourself working with international clients. You might also discover some specific etiquette rules just by watching your coworkers communicate. And it won't just be in-person communications you'll deal with. Almost 300 billion emails are sent and received every day, and that number is only growing. Fortunately, there are useful skills you can learn from those digital communications too. You'll want your emails to be just as professional as your in-person communications. Here are some things that can help you do that. Good writing practices will go a long way to making your emails professional and easy to understand. Emails are naturally more formal than text, but that doesn't mean you have to write the next great novel. Just taking the time to write complete sentences that have a proper spelling and punctuation will make it clear you took the time and consideration in your writing. Emails often get forwarded to other people to read, so write clearly enough so that anyone could understand you. I like to read important emails out loud before I hit send. That way, I can hear if they make sense and catch any typos. And keep in mind, the tone of your emails can change over time. If you find that your team is fairly casual, that's great. Once you get to know them better, you can start being more casual too. But being professional is always a good place to start. A good rule of thumb: would you be proud of what you had written if it were published on the front page of a newspaper? If not, revise it until you are. You also don't want your emails to be too long. Think about what your team member needs to know and get to the point instead of overwhelming them with a wall of text. You'll want to make sure that your emails are clear and concise so that they don't get lost in the shuffle. Otherwise, be sure to give them a TLDR. Let's take a quick look at 2 emails so you can see what I mean. Here's the first email. There's so much written here that it's kind of hard to see where the important information is. And this first paragraph doesn't give me a quick summary of the important takeaways. It's pretty casual too. The greeting is just, "Hey," and there's no sign-off. Plus, I can already spot some typos. Now, let's take a look at the second email. Already, it's less overwhelming, right? Just a few sentences telling me what I need to know. It's clearly organized, and there's a polite greeting and sign-off. This is a good example of an email. Short and to the point, polite and well written, all of the things we've been talking about so far. But what do you do if what you need to say is too long for an email? Well, you might want to set up a meeting instead. It's important to answer in a timely manner as well. You don't want to take so long replying to emails that your coworkers start wondering if you're okay. I always try to answer emails in 24 to 48 hours, even if it's just to give them a timeline for when I'll have the actual answers they're looking for. That way, I can set expectations and they know I'm working on it. That works the other way around too. If you need a response on something specific from one of your team members, be clear about what you need and when you need it so that they can get back to you. I'll even include a date in my subject line and bold dates in the body of my email so it's really clear. Remember, being clear about your need is a big part of being a good communicator. We covered some great ways to improve our professional communication skills, like asking questions, practicing good writing habits, and some email tips and tricks. These will help you communicate clearly and effectively with your team members on any project. It might take some time, but you'll find a communication style that works for you and your team, both in person and online. As long as you're willing to learn, you won't have any problems adapting to different communication expectations you'll see in future jobs. We discussed before how data has limitations. Sometimes you don't have access to the data you need, or your data sources aren't aligned, or your data is unclean. This can definitely be a problem when you're analyzing data, but it can also affect your communication with your stakeholders. That's why it's important to balance your stakeholders' expectations with what is actually possible for a project. We're going to learn about the importance of setting realistic, objective goals and how to best communicate with your stakeholders about problems you might run into. Keep in mind that a lot of things depend on your analysis. Maybe your team can't make a decision without your report, or maybe your initial data work will determine how and where additional data will be gathered. You might remember that we've talked about some situations where it's important to loop stakeholders in. For example, telling your project manager if you're on schedule or if you're having a problem. Now let's look at a real-life example where you need to communicate with stakeholders and what you might do if you run into a problem. Let's say you're working on a project for an insurance company. The company wants to identify common causes of minor car accidents so that they can develop educational materials that encourage safer driving. There's a few early questions you and your team need to answer. What driving habits will you include in your data set? How will you gather this data? How long will it take you to collect and clean that data before you can use it in your analysis? Right away, you'll want to communicate clearly with your stakeholders to answer these questions, so you and your team can set a reasonable and realistic timeline for the project. It can be tempting to tell your stakeholders that you'll have this done in no time, no problem, but setting expectations for a realistic timeline will help you in the long run. Your stakeholders will know what to expect when, and you won't be overworking yourself and missing deadlines because you overpromised. I find that setting expectations early helps me spend my time more productively. So as you're getting started, you'll want to send a high-level schedule with different phases of the project and their approximate start dates. In this case, you and your team establish that you'll need 3 weeks to complete the analysis and provide recommendations. And you let your stakeholders know so they can plan accordingly. Now, let's imagine you're further along in the project and you run into a problem. Maybe drivers have opted into sharing data about their phone usage in the car, but you discover that some sources count GPS usage and some don't in their data. This might add time to your data processing and cleaning and delay some project milestones. You'll want to let your project manager know and maybe work out a new timeline to present to stakeholders. The earlier you can flag these problems, the better. That way, your stakeholders can make necessary changes as soon as possible. Or what if your stakeholders want to add car model or age as possible variables? You'll have to communicate with them about how that might change the model you've built, if it can be added in before the deadlines, and any other obstacles that they need to know so they can decide if it's worth changing at this stage of the project. To help them, you might prepare a report on how their request changes the project timeline or alters the model. You could also outline the pros and cons of that change. You want to help your stakeholders achieve their goals, but it's important to set realistic expectations at every stage of the project. This takes some balance. You've learned about balancing the needs of your team members and stakeholders, but you also need to balance stakeholder expectations and what's possible with the project's resources and limitations. That's why it's important to be realistic and objective and communicate clearly. This will help stakeholders understand the timeline and have confidence in your ability to achieve those goals. So we know communication is key, and we have some good rules to follow our professional communication. Coming up, we'll talk even more about answering stakeholder questions, delivering data, and communicating with your team.
I'm Sarah, and I'm a senior analytical lead at Google. As a data analyst, there's going to be times where you have different stakeholders who have no idea about the amount of time that it takes you to do each project. And in the very beginning, when I'm asked to do a project or to look into something, I always try to give a little bit of expectation settings on the turnaround because most of your stakeholders don't really understand what you do with data and how you get it and how you clean it and put together the story behind it. The other thing that I want to make clear to everyone is that you have to make sure that the data tells you the stories. Sometimes people think that data can answer everything. And sometimes we have to acknowledge that that is simply untrue. I recently worked with a state to figure out why people weren't signing up for the benefits that they needed and deserved. We saw people coming to the site and where they would sign up for those benefits and see if they're qualified. But for some reason, there was something stopping them from taking the step of actually signing up. So I was able to look into it using Google Analytics to try to uncover what is stopping people from taking the action of signing up from these benefits that they need and deserve. And so I go into Google Analytics, I see people are going back between the service page and the unemployment page, back to the service page, back to the unemployment page. And so I came up with a theory that hey, people aren't finding the information that they need in order to take the next step to see if they qualify for these services. The only way that I can actually know why someone left the site without taking action is if I ask them. I would have to survey them. Google Analytics did not give me the data that I would need to 100% back my theory or deny it. So when you're explaining to your stakeholders, hey, I have a theory, this data is telling me a story, however, I can't 100% know due to the limitations of data, you just have to say it. So the way that I communicate that is I say, I have a theory that people are not finding the information that they need in order to take action. Here's the proof points that I have that supports that theory. So what we did was we then made it a little bit easier to find that information. Even though we weren't 100% sure that my theory was correct, we were confident enough to take action, and then we looked back and we saw all the metrics that pointed me to this theory improve. And so that always feels really good when you're able to help a cause that you believe in do better and help more people through data. It makes all the nerdy learning about SQL and everything completely worth it.
We live in a world that loves instant gratification. Whether it's overnight delivery or on-demand movies, we want what we want, and we want it now. But in the data world, speed can sometimes be the enemy of accuracy, especially when collaboration is required. We're going to talk about how to balance speedy answers with right ones, and how to best address these issues by reframing questions and outlining problems. That way, your team members and stakeholders understand what answers they can expect when. As data analysts, we need to know the why behind things like a sales slump, a player's batting average, or rainfall totals. It's not just about the figures, it's about the context too. And getting to the bottom of these things takes time. So if a stakeholder comes knocking on your door, a lot of times that person may not really know what they need. They just know they want it at light speed. But sometimes the pressure gets to us, and even the most experienced data analysts can be tempted to cut corners and provide flawed or unfinished data in the interest of time. When that happens, so much of the story in the data gets lost. That's why communication is one of the most valuable tools for working with teams. It's important to start with structured thinking and a well-planned scope of work, which we talked about earlier. If you start with a clear understanding of your stakeholders' expectations, you can then develop a realistic scope of work that outlines agreed-upon expectations, timelines, milestones, and reports. This way, your team always has a roadmap to guide their actions. And if you're pressured for something that's outside of the scope, you can feel confident setting more realistic expectations. At the end of the day, it's your job to balance fast answers with the right answers, not to mention figuring out what the person is really asking. Now seems like a good time for an example. Imagine your VP of HR shows up at your desk demanding to see how many new hires are completing a training course they've introduced. She says, "There's no way people are going through each section of the course. The human resources team is getting slammed with questions. We should probably just cancel the program." How would you respond? Well, you could log into the system, crunch some numbers, and hand them to your supervisor. That would take no time at all. But the quick answer might not be the most accurate one. So instead, you could reframe her question, outline the problem, challenges, potential solutions, and time frame. You might say, "I can certainly check out the rates of completion, but I sense there may be more to the story here. Could you give me 2 days to run some reports and learn what's really going on?" With more time, you can gain context. You and the VP of HR decide to expand the project timeline so that you can spend time gathering anonymous survey data from new employees about the training course. Their answers provide data that can help you pinpoint exactly why completion rates are so low. Employees are reporting that the course feels confusing and outdated. Because you were able to take time to address the bigger problem, the VP of HR has a better idea about why new employees aren't completing the course and can make new decisions about how to update it. Now the training course is easy to follow and the HR department isn't getting as many questions. Everybody benefits. Redirecting the conversation will help you find the real problem, which leads to more insightful and accurate solutions. But it's important to keep in mind, sometimes you need to be the bearer of bad news, and that's okay. Communicating about problems, potential solutions, and different expectations can help you move forward on a project instead of getting stuck. When it comes to communicating answers with your teams and stakeholders, the fastest answer and most accurate answers aren't usually the same answer. But by making sure that you understand their needs and setting expectations clearly, you can balance speed and accuracy. Just make sure to be clear and upfront and you'll find success. Data has the power to change the world. Think about this. a bank identifies 15 new opportunities to promote a product, resulting in $120 million in revenue. A distribution company figures out a better way to manage shipping, reducing their cost by $500,000. Google creates a new tool that can identify breast cancer tumors in nearby lymph nodes. These are all amazing achievements, but do you know what they have in common? They're all the results of data analytics. You absolutely have the power to change the world as a data analyst, and it starts with how you share data with your team. In this video, we will think through all of the variables you should consider when sharing data. When you successfully deliver data to your team, you can ensure that they're able to make the best possible decisions. Earlier, we learned that speed can sometimes affect accuracy when sharing data-based information with a team. That's why you need a solid process that weights the outcomes and actions of your analysis. So, where do you start? Well, the best solutions start with questions. You might remember from our last video that stakeholders will have a lot of questions, but it's up to you to figure out what they really need. So ask yourself, does your analysis answer the original question? Are there other angles you haven't considered? Can you answer any questions that may get asked by your data and analysis? That last question brings up something else to think about. How detailed should you be when sharing your results? Would a high-level analysis be okay? Above all else, your data analysis should help your team make better, more informed decisions. Here's another example. Imagine a landscaping company is facing rising costs and they can't stay competitive in the bidding process. One question you could ask to solve this problem is, can the company find new suppliers without compromising quality? If you gave them a high-level analysis, you'd probably just include the number of clients and cost of supplies. Here, your stakeholder might object. She's worried that reducing quality will limit the company's ability to stay competitive and keep customers happy. Well, she's got a point. In that case, you need to provide a more detailed data analysis to change her mind. This might mean exploring how customers feel about different brands. You might learn that customers don't have a preference for specific landscape brands, so the company can change to the more affordable suppliers without compromising quality. If you feel comfortable using the data to answer all these questions and considerations, you've probably landed on a solid conclusion. Nice! Now that you understand some of the variables involved with sharing data with a team, like process and outcome, you're one step closer to making sure that your team has all the information they need to make informed, data-driven decisions. Now, it's time to discuss meetings. Meetings are a huge part of how you communicate with team members and stakeholders. Let's cover some easy-to-follow do's and don'ts you can use for meetings, both in person or online, so that you can use these communication best practices in the future. At their core, meetings make it possible for you and your team members or stakeholders to discuss how a project is going. But they can be so much more than that. Whether they're virtual or in person, team meetings can build trust and team spirit. They give you a chance to connect with the people you're working with beyond emails. Another benefit is that knowing who you're working with can give you a better perspective of where your work fits into the larger project. Regular meetings also make it easier to coordinate team goals, which makes it easier to reach your objectives. And with everyone on the same page, your team will be in the best position to help each other when you run into problems too. So whether you're leading a meeting or just attending it, there are best practices you can follow to make sure your meetings are a success. There are some really simple things you can do to make a great meeting. Come prepared, be on time, pay attention, and ask questions. This applies to both meetings you lead and ones you attend. Let's break down how you can follow these to-dos for every meeting. So what do I mean when I say come prepared? Well, a few things. First, bring what you need. If you like to take notes, have your notebook and pens in your bag or your work device on hand. Being prepared also means you should read the meeting agenda ahead of time and be ready to provide any updates on your work. If you're leading the meeting, make sure to prepare your notes and presentations and know what you're going to talk about. And of course, be ready to answer questions. These are some other tips that I like to follow when I'm leading a meeting. First, every meeting should focus on making a clear decision and include the person needed to make that decision. And if there needs to be a meeting in order to make a decision, schedule it immediately. Don't let progress stall by waiting until next week's meeting. Lastly, try to keep the number of people at your meeting under 10 if possible. More people makes it hard to have a collaborative discussion. It's also important to respect your team members' time. The best way to do this is to come to meetings on time. If you're leading the meeting, show up early and set up beforehand so you're ready to start when people arrive. You can do the same thing for online meetings. Try to make sure your technology is working beforehand and that you're watching the clock so you don't miss a meeting accidentally. Staying focused and attentive during a meeting is another great way to respect your team members' time. You don't want to miss something important because you were distracted by something else during a presentation. Paying attention also means asking questions when you need clarification, or if you think there might be a problem with a project plan. And don't be afraid to reach out after a meeting. If you didn't get to ask your question, follow up with the group afterwards and get your answer. When you're the person leading the meeting, make sure you build and send out an agenda beforehand so your team members can come prepared and leave with clear takeaways. You'll also want to keep everyone involved. Try to engage with all your attendees so you don't miss out on any insights from your team members. And let everyone know that you're open to questions after the meeting too. It's a great idea to take notes even when you're leading the meeting. This makes it easier to remember all questions that were asked. Then afterwards, you can follow up with individual team members to answer those questions or send an update to your whole team, depending on who needs that information. Now let's go over what not to do in meetings. There are some obvious don'ts here. You don't want to show up unprepared, late, or distracted for meetings. You also don't want to dominate the conversation, talk over others, or distract people with unfocused discussion. Try to make sure you give other team members a chance to talk and always let them finish their thought before you start speaking. Everyone who is attending your meeting should be giving their input. Provide opportunities for people to speak up, ask questions, call for expertise, and solicit their feedback. You don't want to miss out on their valuable insights. And try to have everyone put their phones or computers on silent when they're not speaking, you included. Now we've learned some best practices you can follow in meetings, like come prepared, be on time, pay attention, and ask questions. We also talked about using meetings productively to make clear decisions and promoting collaborative discussions, and to reach out after a meeting to address questions you or others might have had. You also know what not to do in meetings: showing up unprepared, late, or distracted, or talking over others and missing out on their input. With these tips in mind, you'll be well on your way to productive, positive team meetings. But of course, sometimes there will be conflict in your team. We'll discuss conflict resolution soon. Joining a new team was definitely scary at the beginning, especially at a company like Google where it's really big and everyone is extremely smart. But I really leaned on my manager to understand what I could bring to the table, and that made me feel a lot more comfortable in meetings while sharing my abilities. I found that my best projects start off when the communication is really clear about what's expected. If I leave the meeting where the project is being asked of me, knowing exactly where to start and what I need to do, that allows for me to get it done faster, more efficiently, and getting to the real goal of it, and maybe going an extra step further because I didn't have to spend any time confused on what I needed to be doing. Communication is so important because it gets you to the finish line the most efficiently and also makes you look really good. When I first started, I had a good amount of projects thrown at me and I was really excited, so I went into them without asking too many questions. At first, that was an obstacle because while you can thrive in ambiguity as to what the project objective is can be really harmful when you're actually trying to get the goal done. And I overcame that by simply taking a step back when someone asked me to do the project and just clarifying what that goal was. Once that goal was crisp, I was happy to go into the ambiguity of how to get there, but the goal has to be really objective and clear. I'm Ximena, and I'm a financial analyst. It's normal for conflict to come up in your work life. A lot of what you've learned so far, like managing expectations and communicating effectively, can help you avoid conflict. But sometimes you'll run into conflict anyways. If that happens, there are ways to resolve it and move forward. In this video, we will talk about how conflict could happen and the best ways you can practice conflict resolution. A conflict can pop up for a variety of reasons. Maybe a stakeholder misunderstood the possible outcomes for your project. Maybe you and your team member have very different work styles. Or maybe an important deadline is approaching and people are on edge. Mismatched expectations and miscommunications are some of the most common reasons conflicts happen. Maybe you weren't clear on who was supposed to clean a data set, and nobody cleaned it, delaying a project. Or maybe a teammate sent out an email with all of your insights included, but didn't mention it was your work. And while it can be easy to take conflict personally, it's important to try and be objective and stay focused on the team's goals. Believe it or not, tense moments can actually be opportunities to reevaluate a project and maybe even improve things. So when a problem comes up, there are a few ways you can flip the situation to be more productive and collaborative. One of the best ways you can shift a situation from problematic to productive is to just reframe the problem. Instead of focusing on what went wrong or who to blame, change the question you're starting with. Try asking, how can I help you reach your goal? This creates an opportunity for you and your team members to work together to find a solution instead of feeling frustrated by the problem. Discussion is key to conflict resolution. If you find yourself in the middle of a conflict, try to communicate, start a conversation, or ask things like, are there other important things I should be considering? This gives your team members or stakeholders a chance to fully lay out your concerns. But if you find yourself feeling emotional, give yourself some time to cool off so you can go into the conversation with a clearer head. If I need to write an email during a tense moment, I'll actually save it to drafts and come back to it the next day to reread it before sending, to make sure that I'm being level-headed. And if you find you don't understand what your team member or stakeholder is asking you to do, try to understand the context of their request. Ask them what their end goal is, what story they're trying to tell with the data, or what the big picture is. By turning moments of potential conflict into opportunities to collaborate and move forward, you can resolve tension and get your project back on track. So instead of saying, there's no way I can do that in this time frame, try to reframe it by saying, I would be happy to do that, but it'll just take this amount of time. Let's take a step back so I can better understand what you'd like to do with the data, and we can work together to find the best path forward. And with that, we've reached the end of this section. Great job! Learning how to work with new team members can be a big challenge in starting a new role or a new project. But with the skills you've picked up in these videos, you'll be able to start on the right foot with any new team you join. So far, you've learned about balancing the needs and expectations of your team members and stakeholders. You've also covered how to make sense of your team's roles and focus on the project objective, the importance of clear communication and communication expectations in a workplace, and how to balance the limitation of data with stakeholder asks. Finally, we covered how to have effective team meetings and how to resolve conflicts by thinking collaboratively with your team members. Hopefully now you understand how important communication is to the success of a data analyst. These communication skills might feel a little different from some of the other skills you've been learning in this program, but they're also an important part of your data analyst toolkit and your success as a professional data analyst. And just like all of the other skills you're learning right now, your communication skills will grow with practice and experience.
Hey, I'm Nathan. I'm a principal data analyst in the Trust and Safety organization at Google. I joined the Marine Corps Reserves when I was attending college, and the reserve unit I joined was a field artillery unit. So after a challenging Marine Corps boot camp, I went to Field Artillery Fire Direction Control School. And for those of you that might not know, fire direction control is considered the brains of field artillery. And we used all sorts of computers to do our artillery calculations. But just in case the computers went down, we also were trained how to use slide rules as a backup. And then a year later, had the opportunity to be activated as a truck driver instead of my primary job as a field artilleryman, and was deployed to Iraq to drive trucks for an infantry company. After I got back from Iraq, I finished up my bachelor's degree and then worked as an applications engineer in Austin, Texas, and eventually saw the need to pivot more, to focus more on business. And that's when I really fell in love with data analysis, was when I was learning a lot more about business. It actually took me a couple years when I really sparked an interest in data analysis to land a role where I got to do it full time and really get my hands dirty with the data. Some of the things I did to lay the groundwork to be ready and be qualified for that was I took a Coursera course on R, and I also did some data science hackathons where you spend an entire weekend at some university and they release the data set Friday night, and by Sunday afternoon, you have to come up with some recommendations. So those were two really good ways to really prepare myself, get good experience, and really show a strong interest in data analysis. My first job where I got to do data analysis full time was at a large bank, and I was just in heaven. I got to really do SQL for real. And also I got to use Tableau a ton, got to go to a Tableau conference. It was really cool. Then I was fortunate enough to get an opportunity to move to Google into my current role that's in trust and safety. And what's super exciting and fulfilling about that is that, similar to the military, it has an overall mission of protecting people. So that's super exciting for me. The things that were instilled in me in the Marines that I use to this very day would be attention to detail. That's super important in the military overall, but especially in field artillery. Secondly is the importance of communication. You have your own details locked in. You need to make sure that those are communicated really clearly to other people that you're working with. And the third would be collaboration. In the military, teamwork makes the dream work. You really rely on the team. That's definitely been the case in my post-Marine Corps career and jobs.
Congrats! You've made it through another course. And you know what that means? It's time for the course challenge. You'll take everything you've learned in this course and apply it in these upcoming activities. As always, feel free to review any of the work we did to refresh your memory before the challenge. Once you've finished, we'll meet back here to find out what's coming in the next course. Good luck, you got this. Okay, now that you're done, you're officially ready to take on the next course. Awesome job! But before I tell you about what's ahead, let's take a moment to think about what we've covered so far in the first step of the data analysis process. In this course, we explored effective questions, and we learned how to use quantitative and qualitative data, metrics, and math to connect the dots. We also covered spreadsheet basics, how to apply structured thinking, and key communication skills for working with stakeholders and team members. That's a lot. And now it's time to take what you learned into the next course, where you'll tackle the next step of the data analysis process. Prepare your data. Hallie is going to take over from here. You might remember her from the beginning of the first course. She'll guide you as you learn new, important tools for your work like data types and data structures, bias and credibility in analytics, databases, organizing and protecting your data, and the data community. Thanks for sticking with me through this course. When you're ready, you can go ahead to the first video in the next course. Good luck! You're going to do great!